Now let's discuss the continuity of the two given functions. Let's look at this one first. This is a polynomial function. A polynomial function has no breaks, no asymptotes, no holes, nothing. It's continuous everywhere. It's continuous at every real number. So the function f is continuous in the entire or on the entire real number line. So negative infinity to positive infinity. Now let's look at this function. F of x equals the square root of x squared minus 1. First, let's check where this function is defined. Notice that we have a radical sign and we need to make sure that the quantity under the radical sign is non-negative. It has to be positive or always greater than or equal to 0. It has to be positive, or it's okay for it to be equal to 0, but it cannot be less than 0. So we need to make sure that the quantity under the radical sign, which is x plus 1 times x minus 1, is greater than or equal to 0. Now, let's think about it. This is a product of two numbers, x plus 1 and x minus 1, and we need to make sure it's greater than 0. So there are two cases we need to consider. First, that x plus 1 is positive or equal to 0. And if this is positive, we need to make sure that the other factor is also positive, so that way positive or of course equal to 0, so that way the product is greater than or equal to 0. So we have x minus 1 greater than or equal to 0. If both are positive or 0, then we can be sure that the product is positive or 0. The other case is when x plus 1 is less than or equal to 0. And in that case, which means if this is negative, if one of the factors is negative or 0, then the other better be negative or 0, because negative times negative is positive, and of course if one of them is 0, it's equal to 0, which is still okay. So we're trying to make sure that the quantity under the radical sign is positive or 0. So x minus 1 is less than or equal to 0. So basically the product of two positive numbers is positive and the product of two negative numbers is positive as well. So let's look at the first case when both are greater than or equal to 0. We'll solve for x in this inequality. So we subtract 1 on both sides. So x is greater than or equal to 1. In the other case, we add 1 on both sides. So that way x is greater than or equal to 1. Both have to be true for the quantity x plus 1 times x minus 1 to be greater than or equal to 0. Next, so x is greater than or equal to negative 1 and x is greater than or equal to 1. Both have to be true. So negative 1 on the number line is here, where 0 is here and 1 is here. We need to make sure that the number is greater than or equal to 1. Negative 1, I'm sorry. And we also need to make sure that the number is greater than or equal to 1. So it has to be, both have to be true. So we can replace the two inequalities by x greater than or equal to 1, because if x is greater than or equal to 1, we can be sure that x is greater than or equal to negative 1. So if it's on the right of 1, it is sure to be on the right of negative 1. So we can replace the two inequalities by the one inequality, which is x greater than or equal to 1. Now let's look at x plus 1 less than or equal to 0. Let's solve for x. So that would be x less than or equal to -1, and let's solve for x by adding 1 on both sides. So x is less than or equal to +1. So let's look at the number line again. So we have -1 and then of course 0 in the middle and +1 on the right. We need to make sure that x is less than or equal to -1. And we also need to make sure that x is less than or equal to +1. When I say less than, it's to the left of or equal to, so that's why I have a dot, a solid dot there. So for both to be true, we need to make sure, let's see the overlap. For both to be true, we need to make sure that x is less than or equal to the smaller of the two numbers. If x is to the left of x equals -1, if it's to the left of -1, we can be sure that it is to the left of +1 as well, which means if x is less than or equal to -1, we can be sure that it is less than +1 as well. So remember, we started off with two cases. It could be both positive, which is on the left, or both negative, and that's how we got the two inequalities, which is x greater than or equal to +1 or x less than or equal to -1. So if x is less than or equal to -1 or x is greater than or equal to +1. So that is -infinity to -1, including 1. So put a square bracket here. Union, which means or, x greater than or equal to 1. So that's starting from 1 going to +infinity. So the function is continuous in this interval.